Perfect. All right. Let's play math. So the homework was probably a little easier last night. So we'll definitely hit that. We'll go over it after we get done this. So let's start hitting these rules for exponents. And I think by next week we're actually ready to take the capstone.
No way, dude.
Yeah,
I'm not ready. I've not looked at the school
you're gonna
once.
knock it out of the park. It's gonna be awesome. All right. Rules for exponents. So we know that when we are multiplying exponents, you add your multiplying bases, you add the exponents. Divide, tug of war. And then power to power. Remember, exponents are like bunnies. They multiply when they're on top. Right? You don't understand that? Talk to your anatomy teacher. All right. So what connection can be made between logarithms and exponents? So first off, if you just have log as itself and you don't see that it's a base something, what base does it always default to? 10. Okay? So this is basically saying, hey, log base 10 of 1,000 is 3, because 10 to the third power is the same thing. Okay? Log base 32 or log base 2 of 32. Well, you have to understand that 32 is 2, 4, 8, 16, 32. So 2 to the 5th. So the answer to this comes out to be 5. Is that all right? Everyone happy with that? And then let's complete this table. I know yours is a little blurry on yours. So the basic rule is log base b of u. And the next one is log base b of v. And log base b of uv. Okay, so this first one just comes out to 1. This next one comes out to
0.0.
What is that? Log base. So think about that. 0.1 is equal to 1 over 10. I would make the 10 a negative, have a negative exponent. Right? And then log base 2 of 4, you have to make 4 is equal to 2 squared. So log base 2 of 2 squared is just the exponent 2. That okay so far? Log base 100, that would be 10 squared. You have to realize that would be the same thing as 10 squared. So that's just 2. 0.001 is 1 over 100, which is 1 over 10 squared. So this has to be a negative 2 because it's a denominator. And log base 2 of 8. 8 is the same thing as 2 to the third. So my answer here is 3. Seem good still? Let's see. Log base uv. I don't know why we're doing this, because this one just should be a 3. I mean, we could say that this is the same thing as 10 squared times 10, which is 10 to the third. That's why I gave it 3. This one's 1 over 1,000. So 1,000 is 10 to the third. So this gives me a negative 3 because I'd have an exponent in the denominator. 32, 2, 4, 8, 16, 32. So this is 2 to the 5th. So my answer here is just 5. A-okay? Yep. Nothing too magical. Okay.
Wait, Stir.
Yeah.
Can we make a conjecture about how to find the log of a product?
No.
What?
Log of a product?
It's on the bottom. I was just curious.
Ooh.
I'm not gonna lose my pencil from the
So, just a little show and tell. If you're multiplying two things together, this becomes log u plus log v. But that's where we'll start hitting. So that's how we expand an
Is
exponent.
it like ultraviolet radiation?
Yes, it is. Yeah. So don't stare at it directly. All right. How can we rewrite 125 as a power? That's 5 to the third. We can make it as a product as 5 times 5 times 5, or 25 times 5. So our conjecture of log products is I guess we could say this. Log of 125 is equal to log 25 plus log 5. Or we can make it log 5, log 5, log 5 all being added. So can we use it to find the log of 125? Well, the hard thing on that is 125 I can't make into any type of base 10. 10 to some power isn't going to be 125. So at this point, no. Okay, log of quotients. Well, let's take care of the 1,000 over 100 is 10. So this becomes log 10, and log base 10 of 10 is equal to 1. So cancel out those three, so this becomes log 100, which is log 10 squared, so that's equal to 2. And then over 1,000, cancel 1, 2, 3, 1, 2, 3. So those three. So this just becomes log 10, which equals 1. Is anybody wowed by the magic yet? Not quite. Good. All right, so let's see. So properties of logarithms. Let b us and v be positive numbers such that b is not equal to 1. Okay, so our basis is 1. And our product property, if we are multiplying, if we had like 5 and x, we could make it 5. You expand it. If it's quotient, the only difference is you have a subtraction sign in there. And if you have a power to a power, logarithms bring the exponent down front. So those are all properties we will see. Okay. Then we go from there. So use each of the properties of logs to evaluate each expression. Well, first thing I'm going to do is I'm going to make 8 2 to the third. I'm going to make 16 2 to the fourth. They are the same base, so I could put them together to give me log base 2 of 2 raised to the 7th. Or I could say this. I expand it, log base 2 to the third plus log base 2 to the fourth. The exponents now can come down front. And as long as I have the same bases on each of those, that's going to work. So I get 3 plus 4, which is 7. Number 2, let's change 8 to be 2 to the third. So then I get 2 to the third. So power to power means I multiply the exponents. So I'm going to make 8 2 to the third power. So I get log base 2 of 2 to the third, multiply the exponents. That gives me log base 2 of 2 to the 9th. So my answer comes out to just be 9. So as long as this and this match, they cancel each other out, which is kind of a beautiful thing. Natural log and e are inverses of each other. So the exponent becomes my answer. If I wanted to expand this one, I get log base 3 of 1 minus, because of dividing, log base 3 of 27. Log base 3 of 1, that's 0. 27 is 3 to the third. So I'll make that log base 3 of 3 to the third. So this right here cancels. So I just get 3. So I get 0 minus 3. So I just come up with an answer of negative 3. Everything A-okay with that? Mm-hmm. Okay. Looks like number 5, we incorporate natural log. Natural log has the same expansion rules that log does. So this is going to become ln 1 minus ln e to the 5th. Natural log of 1 is 0 minus, well, this exponent comes down front, 5 ln e. Ln e cancel each other out, so I wind up with 0 minus 5, which is just negative 5. And then let's figure out this one a little bit. So this is tenths, hundredths, thousandths. So this is log of 1 over 1,000 raised to the 5th. I can bring that 5 out front, so I'm going to get this. If the log's by itself, it's base 10, so let's change 1,000 to base 10, so it's over 10 to the 3rd. And then if I expand this a little bit, I'm going to get 5 log 1 minus 5 log 10 to the 3rd. This exponent comes down front, gets multiplied with that. So this right here just gives me an answer of 0 minus 5 times 3 log 10. Log 10 is 1. And then do the multiplication. 0 minus 15. So negative 15 is my answer. Moving right along, doing all right? Questions at this point? Yay. Okay, let's expand each expression. So I'm going to get log base 3 of 8 plus log base 3 of x. I can change 8 to 2 to the 3rd. So this becomes log base 3 of 2, because 8 was 2 to the 3rd, bring the exponent out front, plus log base 3 of x. That is supposed to be an x. Anyone want to take a shot at that? It's a times b times c. How do I expand it? Log a plus log b plus log c. Done. That's it. Okay, so when you're multiplying things together and we're doing the log of that, we can expand it, saying the log of the first plus the log of the second plus the log of the third. And then natural log of dividing. Natural log has the same properties, so we're going to make a subtraction sign. I can't convert 5 or... Here you go.
Thank you.
We can 5 and 6 I can't change to a different base to have it raised to different exponents, so just leave it as is. And then the only thing I can do here is log and natural log have the same thing, so the exponent comes down front, so I wind up with 3 ln x. Logarithms aren't that tough, are they? Basically, 4 basic rules. Expand by multiplying where you add everything, dividing where we subtract. So if it's in the denominator, we'll have subtract. Okay. Let me see if I can jump to this. Is that okay? What did I do? I expanded it to log base 3 of 5 plus log base 3 of x squared, but because it's x squared, I bring the exponent down front. And then, so the missing step, and then plus log base 3 of y to the third, again, bring the exponent down front. 25 is 5 squared, yes? Mm-hmm. So that's going to be 5 squared. So this is going to give me 3 log base 5 of x minus 2 log base 5 of 5. Log base 5 of 5 is 1. Done. do I make a radical into an exponent? If it's a square root, it's raised to the what power?
Fraction.
It's a fraction. So you have to recognize that this and the x is the only thing raised to the 1/2. Then if I expand it, these are being multiplied. The 1/2 can come down front. Log base 3 of 5 plus 1/2 log base 3 of x. What exponent is this one then?
1/3.
1/3. Good. Expand it, bring the exponent down front on the top one. 7 of x. And then minus log base 7 of 7. What's log base 7 of 7? 1. That's 1/3. Log base 7 of x minus 1. That's it. That's the happy stuff. One last page.
Yes, sir.
Cool. Got plenty of time. So then, if we can expand them, we can also condense them. So if you have a plus sign, that means you're multiplying. If there's a subtraction sign, it becomes a fraction, and make sure you reduce the fraction. So the first one is just going to become log of 5c. Done. Condenses nicely. This one's going to become log 6 over 15. I can reduce 6 over 15. 3 goes into both. So 2 over 5. Sometimes they will put it like this. It means the same thing to me. I don't think one's more correct than the other. Natural log has the same condensed rules. So I have natural log 28 over 7. 28 over 7 reduces to 4, or 4 over 1, which is just 4. And then remember, what is this really?
Exponent.
It's an exponent. So this is going to become log base 3 of 6, no exponent on 6, and x to the 3rd. Done. So the condense and the expand are great rules.
Nice.
All right, now use the properties of logs to evaluate the expression. Okay. So let's put things back together. So I have log 200 plus log of 8 to the 1/3. What's the 1/3 power of 8? 2. Does everyone agree with that so far? Put them back together so I get log of 2 times 200, which is 400. You can then probably say, well, I know that 400 is the same thing as 100 plus log 4. You agree with that? What's log base 10 of 100? Make 100 and make log base 10. Make 100 base 10. Make 100 in base 10 form. 10 to the what? So this right here becomes just 2. So 2 plus log 4. I guess you could convert log 4 to 2 squared, but you could leave it like that. If I condense this one, I get log base 5 of 50 over 2. 50 over 2 is 25. 25 in base 5 form is So I get 5 squared. Being those cancel out, so my answer to this one just comes out to 2. Is that everything? Dude!
No way, man.
Wait, got done with that. So your assignment for next time will be worksheet H. Now let's hit questions. So worksheet H will be your next time's assignment. Okay? And let's take a look at our worksheet G if there's any questions. But while you're taking those out, we'll go into questions on that. This is what I was thinking about doing for the capstone test. I'm presenting it tomorrow, so I just wanted to put it out there to you all. Just think about it. I would like a few things. I don't want to give up a class period to give the next 2 capstone tests. Okay, there's no reason to. So I think I would like to do this. And I'm just putting this on you. Just give me feedback if you think legitimate. Well, I'd love to do it for homework, but unfortunately then she was working with each other and everyone's acing it, which I would love you all to ace, but I would like, and this isn't official yet, but this is what I'm proposing to my group tomorrow for Algebra 2. I would like you to come in during one of your off periods to do the capstone. Now, hang on before you're like,
No. I'll come in the morning.
the rest of my proposal is this. If you score a 7 out of 10,
You wipe our lowest test grade out.
no, not quite that good. Yeah, okay, I'll wipe out your lowest, but you have to make sure you take all of them.
Oh, okay. That's the deal.
He'd come in, I'm done. You have your name on it, buddy.
My lowest test grade.
If you get a 7 out of 10, I will put a quiz score of a 20 out of 20 in for you. If you get an 8, 9, or a 10, I would then look at curving you
Yep. Cool.
at the end of the semester.
Yep. That's what we're doing.
Peyton's forward, so we must be doing it. So,
Sophomore class.
but that just means that you would have to come in either before school or one of your off periods. Now, here's the thing. So if you were to, let's say you come in and you get a 5 on it.
Right.
Well, I do have a great review that's on Schoology, correct?
Yeah, you posted it.
Yeah, and some of you have taken that, and some of you have done fine. I think right now, if you went and did that Schoology thing, I think you would be pretty darn close to getting it 100% correct. And remember, I'm putting that in as a 20 out of 20 homework grade. So it is something that I'm huh?
Quiz grade.
Oh, for the Schoology. The Illuminate, yes, quiz grade.
Wait, so that we can just we need to do that, or that's just an option on school?
I would really like you to do it. That way you're prepared. That way you come in and get a 10 out of 10 on the Illuminate. So then you're getting a 20 out of 20 quiz grade.
And then we can pass
And then when you're sitting there at that 79.2, you kind of rest a little easier, saying, "Dude, I got the B."
Yeah, 89.
89. Sorry, I didn't mean to insult you. Sound like a deal?
Yeah.
So that's what I'm proposing tomorrow. Now, we've heard, yes, we're doing it, but I want all. It's not really up to me at this point. I mean, yes, it is my classroom, so I could probably get away with it no matter what, but I won't. I respect my other teachers I work with. Does anyone see a negative ramification to that?
No.
What if we don't get a 7 out of 10?
Because
Then you can redo it.
Guys, it's
How many
literally
times
just
can you retake it?
As many times as you want to get best score.
So if I get a 7, then I want to get like a 9, and then I want to get a 10, I can just. Are they the same questions?
It's a similar question, just change the numbers a little bit.
Why don't we just give us all of the answers so then we all can get a correct?
Yeah.
You got it.
That sounds like a smart.
So one of the answers is guaranteed to be A. One of them.
Whoa.
Actually, I thought
What
they
if
were
it's
all
not?
C.
How about just all of them are
But
A?
it's not.
I'll try and change that for you. And then I get the kid that puts D all the way down.
I have a question on the worksheet.
Okay, let's hit that worksheet. Thanks for letting me tug your knowledge. All right, Clay, what do you got? We're on 9G, yes?
Yeah, like, how do you, it's like the first 12 or whatever, it says rewrite each equation and log of 1, what is that?
All right, so let's look at number 1. 4 to the x equals 16. So if I want to write it as a log, I'm going to do this. I'm going to start here, and I'm still doing my shell. So this becomes log base 4 of 16 is equal to x. Okay? If the exponent's on the other side, just take your whole question and flip your whole question, but it doesn't look like any of those are goofy. So does that help you on any of those? That's all the exact same operation. Number 10 might be a question because it's a fraction. So we have x to the negative 4
But x would still equal 2.
equals 1 over 16. So I'm going to start here, and I'm going to shell it around. So log base x of 1/16 is equal to negative 4. Yeah.
Do 37.
37. 37 is in the house. Ready for me to switch? 37. We got log base x of 1 over 64 is equal to negative 2. So, and these ones, they wanted us to solve for x, so we want to solve it. So I'm going to go x to the negative 2 is equal to 1 over 64. Is that okay so far? 8. So I'm going to make that 1 over x squared equals 1 over, what can I do to 64 to put it as a squared term? So you said 8?
Yeah.
8 squared is 64, right?
Yeah.
2 to the 6th is also, so would 2 to the 6th work here? I'd say no, because these exponents aren't going to match. So I would cross that one and go 1 over x squared equals 1 over 8 squared. Is that all right? So what's my base in this?
Negative 8.
Just 8. So x equals 8. So log base 8 of 1 over 64 is negative 2. So that takes care of that 1 over 64 because it's a negative 2.
But then wouldn't it be positive 2?
Because if I rewrote this with the base 8 in there,
Oh, because it's an even, so it's going to be positive. Okay, yeah.
so that works.
Because, like, even is always positive, and then odd
Works for me.
is a positive 1.
Well, the fraction means you're getting the negative.
Yeah.
Other questions off of your worksheet? Yeah. 3. Log base 4 of 4 raised to the negative 0.38. So this one's already solved for us. We don't have to go and convert it. Because I have this, that just says the exponent comes down. So you have x equals negative 0.38. What are other questions off that homework? Anything else going once? 13? So I could do this two different ways. I could go ahead and convert it to an exponent if I wanted to. So I get 2 to the x equals 128. How do I make 128 in base 2 form? So I got 2, 4, 8, 16, 32, 64, 128. So 2 to the 7th. So x is equal to 7. Or you could have left it as it is and realize 128 is 2 to the 7th. Because you have that, you get 7 is equal to x. Both ways are 100% correct way to do it. So some minds will work one way, some will work the other. Nothing's wrong with your mind if it works either way. 40. Log base 5/3 x equals -2. Is that okay? This one I would definitely want to make it as an exponent, so use the shell. So 5/3 to the -2 power is equal to x. Flip it over. So it's now to a positive exponent. So that's equal to 9/25. Everybody happy? Any other questions?
Can I hear a story?
Story?
Yeah, you asked a question.
All right, make sure your names are on your assignment and pass that forward. If you're handing anything else forward, please pass that forward as well.
Another one.